Hey, what's up, guys? How's it going? And in this video, I'm going to go through another LeetCode problem. This is question 1423, maximum points you can obtain from cards. And so this question was asked by Google and Apple and by Uber. So let's take a look at the question. And there are several cards arranged in a row, and each card has an associated number of points. The points are given in the integer array, which is called card point. In one step, you can take one card from the beginning, and here this is the keyword, or the end. So we are only two choices for each step. And we have to take exactly k cards. So we have k decisions to make. And each step we have to decide either is beginning or is the end. Your score is the sum of the points of the card you have taken, given the integer array, the card point, and integer k. Return the maximum score we can obtain. So there's an example in here. This is the card point array, and the k is 3. So and the output is 12, and the maximum, so which is the maximum score is the 12, which is comes from 5, 6, and 1, because we always taking the end of the row. Because in this case, if we take on, let's say, the left, always the beginning will be 1, 2, and 3. So possible options will be taking always taking the beginning 3, 2, 1, or we can go from this direction 2, 1, and 1, or 1, 1, and 6, or 1, 6, and 5, which is the maximum maximum score. And this is a sliding window problem. And let me show you how I approached this problem. So let's look back to this array, which is 1, 2, 3, 4, 5, 6, 1, which is that. And then we can create another array. We call it array times 2, which is a copy. So copy the original array 1, 2, 3, 4, 5, 6, 1, and then there's an exact same copy that follows it. So 1, 2, 3, 4, 5, 6, 1 again, and then I have the labels in here. It means index, and all the way from 0 to 13, and we have 14 indices. So, and for this array, we have 7 components. 1, 2, all the way here. We have 7 elements. So n equals to 7, and k for this problem set we have 3. So k minus 4, n minus k equals to 4, and then that's where we can choose a starting point for the sliding window problem for the index. So this will be the first window, which is this guy 5, 6, 1, 5, 6, 1, and this is the index. And n minus k will give us a starting point for the first window. As we can see, this first window, and because this problem has a we take a look at the window size is 3. So this is exactly the window size 5, 6, and 1. So there's the first window, and the window size is 5, 6, and the window size is 3. And how many windows we can look at and to choose the maximum from would be k plus 1, which is we can look at exactly 4 windows. So I'm going to walk through this sliding window problem in the code. I mean, we also can apply the brute force approach, which will be much slower, and this this is much faster. This slide window problem. So let's look at the code right now together. And first, we can look at the length of the car point, which is n, which is this guy over here. In this case, is 7. And then if k is equal to n, and in this case, the k is exactly same as the maximum number possible, and then it will return all the sum of all the numbers, and that is for example number 3, right? So k is equal to 7, and we have exactly 7 elements, and this is a corner case is also interesting, and this if statement captures that corner case. And if k the window size is equal to 0, and that returns a 0, and then we have a temp, which is this array, right? It has the array itself, and then it comes exactly the same array, so it duplicates itself. And then this is how we can create that array, and original array times 2. And then we look at the initial starting point. I mean the starting point for the first window, and that is from the n minus k in here. And then we have the first, the running sum, the sum of the first window right here. So we slice this temporary array from the first starting point all the way to taking the k element, because the k is the size of the window. So this running sum will give us, the first running sum will give us the sum of the numbers in the first window. And of course, we have only one window, and the maximum sum will be just equal to that sum of that window. And then next step is to look at the remaining k minus 1 windows. Sorry, the remaining k windows, because we have in total we will have a k plus 1 window, and we have look at the first one, so we have k remaining. This one can speed up the process a little bit, because each time when we have, instead of summing all the windows, and this can speed up the process and reduce the big O, because as you can see, each time when we move the window, for example, when we move from the green window to the brown window, these two elements are the same, right? So, and 6 and 1, they are the same. And when we go from here, the green one to the brown one, what we do is subtracting this number and then adding this number. So this is exactly what it's doing, subtracting the old number that we don't need anymore, and then adding the new number. This is one approach to do it. Another approach to just create a brand new sum, but this is gonna be slow, because repeating the work, right? Because we have already these two sums. These two numbers is already in the prior sum, and then we want to utilize that information and then don't do the 6 plus 1 again, right? Because we have already done that in the prior window, and this is much faster. Because if we do the new sums for every window, that will be a big O of the window size. In this case is K. However, in this case, when we minus the old number and then plus the new number, this one will be a constant time, O of 1. So this is faster. And then we keep comparing the current max sum to the running sum, and then keep comparing that, and then return the champion, which is the highest number. So in terms of time complexity, if k is equal to n, and then we summing all the numbers, will be the big O of n. In this case, it's same as big O of k. And that's the corner case. And if it is not in the corner case, and there's a for loop in here, we are looping through the k cases, and there will be a big O of k as well. So the entire, this big O of 1. Also, there is a sum in here. This is a big O of k. So overall is a so big O of k plus big O of k plus big O of k, and then this big O of k times big O of 1. So big O of 3k, that's time complexity. So the constant got dropped off, and the time complexity will be big O of k in this case. And in terms of space complexity, and we're creating a new temp array, and that's take up the size of that is twice of the original, so that will be big O of 2n, and that's it. So the rest does not take up much space. So let's take a look at the performance, and the submission is 340 milliseconds, and it's faster than more than 90% for the Python code. As you can see, it's pretty efficient, and the code has been saved on Google Colab, and I will leave the link to the Google Colab in the description down below. If you like this video, please hit the like button and subscribe to the channel. And I hope you enjoyed this video, and see you next time. Thank you for watching. Bye bye.